All right, well, thank you. So I'm going to do a little bit of a different presentation. I'm really not going to talk about NETINT, although the topic is closely associated. What I want to cover in the next few minutes is really why ultra-low latency is going to require a move from software encoding to hardware. And just a couple benchmarks here, to remind us, interactive applications in video are becoming not only hot and desired by our consumers, our end viewers, but they need very low latency. So less than 1 second is typical. So anything with a data feed, if you are broadcasting video and there's a Twitter feed next to it, that 5, 10, 20 seconds of delay can be super annoying. Cloud gaming, 150 milliseconds is at the absolute top end of what's acceptable. Really, it needs to get closer to about 50 milliseconds, which is what Metaverse VR requires. And then really important data point here. The video game industry, I don't know how many of you realize this, is double the size of our industry. It's $200 billion. All of video is about $100 billion. Video traffic on the internet, we all have seen the Cisco numbers, of course, and everybody knows 82% of video traffic. Traffic on the internet is video. But what you may not realize is if you look inside that traffic, live stream video. So live video is growing at 15x. So it's a 15x increase. And if you look at absolute size, you can see like long form VOD still occupies the majority of video that's getting streamed. But in terms of growth, it is all about live video. So what does that mean? What that means is that developers need hardware, because latency, speed, and then cost drivers, and now power consumption, energy use, is becoming a very, very significant driver if you're looking at encoding operations. This is from the 2021 BitMovin developer study, which it has some very, very useful data in it. And I just pulled out 2 survey questions that I found really interesting. The one on the left is the question of what challenges developers are facing today. So it was just a list of challenges. Number 1 was live low latency by a wide margin. And then you can kind of read down it, what other things are keeping developers up at night. If you correlate that to what those same developers said were the highest opportunities for innovation, it's a low latency and live streaming. Now, you can do live, and you can do live in software, and you can do live in software. It's somewhat of an economical, cost basis, but you cannot do live in software at ultra low latency. It's not possible. So when we look at what developers are using today, this also is from the BitMovin study. Super interesting that hardware today is used slightly more than software for live. And that's a huge opportunity because, frankly, other than, and I'm going to show you some information about GPU, comparing to GPU, and then what we focus on building custom ASICs, is that when you look at GPU and you consider that if you look at 10,000, this is data for 10,000 live streams, 1080p, you would need 1,200 servers running, and this would be like, we used Intel SVT, and this is H.264. You can see all the cost data. GPU significantly reduces that to 250 servers, and that's our test was NVIDIA T4s. But you go to ASICs, and now you're 32 servers. And of course, you can look at the numbers there to get a cost comparison. So as it gets overused, it is definitely a no-brainer, to be looking at hardware, moving beyond software, and then ASICs represent a really, really tremendous opportunity. So the theme of what you're going to hear me talk about here in the panel is really all around the fact that without hardware encoding, pretty much all of the exciting new workflows, whether it's metaverse, whether it's AR, VR, whether it's cloud gaming, high-scale interactive, they're not even possible. Thank you.
as we squeeze the latency down and we go from however long you want, 10 seconds, all the way down to the incredibly fast milliseconds that we were looking at, what are the extra problems that turn up? What is it that we are suddenly faced with, which if we had 2 seconds to do it, it would be okay from your perspective?
Yeah, I'll comment on that. So, first of all, I think it's really important to draw a distinction of an HTTP streaming protocol, so where we're using HLS or Dash traditionally, and the lower bound is really 7 to 10 seconds. And I know, there's LL Dash, LL HLS, there's demos all over the floor here. But I think in the wild, it's really about 7 to 10 seconds. So I want to draw this distinction that when we say low latency, a lot of times what people are talking about is the absolute lowest bound of HTTP streaming, effectively. As soon as you get to sub-second, there are proprietary approaches, and of course, you can comment on this. And then there's WebRTC, the technology stack of WebRTC. So the reason why I make that point, I think it's important for us to even talk about, is when we're talking about broadcast, 100% of the time it's going to be an HTTP live streaming. So the minute that somebody comes to me and we enter into a conversation and they're saying, we're really, we have a benchmark, or we have a requirement to get to 2 to 3 seconds. It basically, in a lot of cases, is not possible to do that reliably. As soon as you're down into 1 second and below, it's only WebRTC. That's the technology stack. Now there's a lot of optimizations around that. So what are the challenges? I think the challenges is that usually the workflows in the environments that are in place today are just not really, for a lot of folks, are just not capable of supporting LLHLS, LL Dash. There's player changes. There's how do you handle it across multiple devices. So if you have a controlled, you have a set-top box, and you know that you're distributing only to that set-top box, well, then that's a very different scenario, right? But if you're across the connected TV ecosystem, you're on iOS, you're on Android, you're on multiple media player SDKs, you're on game console SDKs, it gets complex extremely fast. And the problem is that as service providers here know, you're always battling being able to give your viewers who are on premium devices this top-end experience, but then what do you do for everyone else? And you just, it gets really, really complex. So you can do demos on a high-end device and show this incredible experience, but like 95% of your consumers aren't on those devices. So what do you do?
Mark, you're talking about hardware encoding.
Yes.
Now, the numbers you put up were very impressive,
yeah,
which I think makes it a little bit easier for you. But coming into a world which seems to be all about let's move this into software and let's move that into the cloud, it's an interesting approach. But clearly there's some factors coming into play. What is it about, let's say, GPUs, which even if they did use more CO2, what is it that really stops them being as effective as the ASIC approach?
Yeah, so I'll answer that with, first of all, a 30-second of what an ASIC is, just in case maybe not everyone's familiar. Please. So I think everybody knows what a GPU is, graphics processor unit. And over the many years that GPU has existed, hardwired, you can think of it, video encoders have been built in. So like on NVIDIA, there's a well-known NVINC codecs and encoders. So, that's the GPU. And when most people say, oh, we're using NVIDIA, although there are accelerated software codecs that use the GPU, in my experience, what they're really saying is we use the hardwired encoder that's in silicon on the GPU, whichever model they're using. An ASIC has the advantage that it is a purpose-built chip that is designed to do a specific function. And in our case, we designed it to take the entire software encoding stack and implement that in silicon. So the advantage is that silicon uses incredibly low power, or requires incredibly low power. Just to give just one benchmark, our little module, we have a little U.2 module, just plugs in an SSD slot. It can encode 8 1080p streams simultaneously at about the quality, if you're familiar with X264, somewhere between slow and medium, and this is live. So to encode in software X264 live, in some cases, you're going to get multiple streams on a CPU. You might get 2 if you're lucky. And that's if you're running, 16 cores fully loaded, maybe 24 cores fully loaded. So the density is amazing. This little module uses 7 watts.
So let's talk about some use cases. I mean, what types of projects have been enabled by what you've been doing?
Yeah, so I think in the program description there's a little blurb about one project that we can talk publicly about, and that is a very large cloud gaming platform that gets up to 100 million concurrent players at peak. There's a couple very popular games. It's run by Tencent, and it's a mobile. This is when I say cloud gaming, this is not, like sports betting. I mean, this is live. You're playing, except there is no console. You're playing over the network, over the cellular network. Very low latency, very, very high user experience. And that's one application. We actually have multiple cloud gaming implementations out in the field, so it's not the only one, but that's a very, very popular one for us. Another one that's really popular is, call it social user-generated live streams. So you can imagine a social platform that might typically have 15-second videos that are files, and you can imagine the kind of volume they get on live. So that would be another application. And then we are seeing some really interesting movement in the broadcast world, where there are managed service platforms, so whether telcos or maybe in the cable industry, who are starting to think about and are actually starting to build POCs and are starting to do work. So it's not just thinking, it's actually building to use WebRTC, interestingly enough, as a way to bypass the CDN. If you're going to reduce your whole latency of the stream, well, you need highly dense, very efficient encoders. And it also opens up some very interesting opportunities where you can have special interest channels, niche channels. Now, why am I limited by my QAM segments, as an example? So maybe I want to have, and I'm just saying hypothetically, maybe I want to offer my consumer 1,000 channels. In the traditional broadcast world, that would be just way too prohibitively expensive, but in this kind of a world, OTT world, and then as you begin to think about bypassing the CDN, and when you're talking very high, and then when I say CDN, I'm talking about, again, HTTP, very traditional CDN architecture. All of a sudden, it opens up possibilities and business models and just content options that just simply, it wasn't even possible before. So that's another.
Thanks. What do you think's what's changed over the last few years? In terms of you can either think about the technologies. Obviously, there are new protocols and technologies coming along. HESP being one of them. That's great. But have we, in terms of the business and business maturity, are we closer to seeing larger adoption within what we would consider the IBC broadcast space? Mark?
Yeah, I'll comment on that. I think we are closer. I notice, here the conversations are less sort of technical and, gee, wouldn't it be cool if, and more, advanced in either their thinking or around, and I totally agree about the business case, about really driving, where a lot of it, there's at least maybe not a fully fleshed out business case yet, but it's well down the road. And so then now it's technology searching for, this is what we want to do. We're pretty clear that there's an opportunity, there's a product we want to build, whatever it is. Now, what's the appropriate technology for it? So in that regard, I would say yes, we're definitely more advanced. 3-4 years ago, it was, I don't know, 2018, certainly 2019, you couldn't walk the floor and every booth was a low latency demo. Every booth, it felt like anyway. And that was more just about showing, see, look, we can do it. Now it's like, okay, we can do it. Now there's a lot more refinement. That's exciting, and that's good.
Mark, what do you think's the number one thing you'd love to fix in this whole discussion?
So there is and I'm going to use the word fragmentation. Normally that's like very negative, like, oh, it's fragmented, so it's a terrible thing. But there are different technology approaches. There's different, like even we talked about, HTTP, live streaming approaches. So, LL-, LLHLS. You have a proprietary under 1 second method of streaming. You have technology. There's the WebRTC stack. And that's what I mean by fragmentation. So it's not a bad thing. And it's not even that somebody has to sort of lose and somebody wins. But it always creates just questions, or some might even say confusion, because somebody might only be aware of one particular approach. Maybe that fits their need, maybe not. But if they don't know that there's another adjacent solution that is a better fit, they might conclude, yeah, we can't do that, when in reality they can. So I think, again, as I like the maturity, as these experiences begin to get rolled out in the wild, as I like to say, which is to say beyond trade show demos and lab evaluations, then it's going to actually help. And I think it'll actually open up more opportunities, because then there'll be reference points. And there'll be some reference points that'll be, oh, don't do that, but there'll be other reference points that are very positive and that we can look to. So that's kind of how I see the discussion playing out. 3-4 years ago, as we said, it was just any way to show, hey, look, it's under a second, and look how amazing this is, or under 3 seconds. Now we're starting to get business cases behind it. Now there's some early implementations of some of these technologies, and it's just only going to further kind of get refined. So.
Yeah, I agree. I mean, overall, this has been very positive because it's clear that we are moving to a position where we're going to be actually seeing much more low latency streaming. We need to wrap up now. It's been an absolute pleasure. Thank you very much to PJ and Mark and Oliver.